Welcome back to part 2 of hyperbolas. So now we got them in conic form, and we have to put them in standard form and then do all the same things that we just did. But again, we've got this now in conic form, so we're going to have to do a little bit of completing the square with this. So first we check to see, how do we know that if it's an ellipse? Well, or I'm sorry, a hyperbola. If you look at it, we've got 16x squared minus y squared right there. We've got a minus that y squared, which is going to create some problems, but we can deal with them. But since we've got that minus y squared, we know right away that it is going to be an ellipse because we've got x squared minus y squared, and they've got numbers up front. Okay, so just like we've always done when we are simplifying these, we're going to go ahead and rewrite them, putting our x's together and our y's together, and because it has to equal 1, we'll move the number to the other side. So that's 16x squared plus 64x minus y squared plus 2y is going to equal negative 47. Okay, so there's step 1. Step 2, we always want our x squared value to be positive and 1. So we're going to factor out a 16. So we factor out a 16, that's going to be x squared plus 4x, and we're just going to go ahead and fill in the box at this point. Half of 4 is 2, 2 squared is 4, so we're going to put a 4 inside the box. Minus, and this is where it gets a little bit tricky, because we're actually factoring out a minus from that y squared. So this is going to be minus, and if I take out a minus, that's going to leave us with y squared minus 2y. Again, because if you think about this, if I distribute that negative back in there, that's negative y squared plus 2y, which is what I have. So in fact, we're factoring out that negative, but we need to make sure that we do it from both parts. Okay, we're going to go ahead and complete the square, but remember this is always a plus. Half of 2 is 1, 1 squared is 1. So then that's going to equal negative 47 plus, now we've got to take 16 times 4, which we said was 64. So we're going to add on here 64, and of course I run out of room. But now we got to be careful. That negative needs to be distributed, so I didn't actually add 1, I subtracted 1. So we got to subtract 1 from both sides. Okay. So then that leaves us with 16 times x plus 2 squared minus y minus 1 squared equals, you put that all together, you get 16. And divide by 16. So that leaves us with x plus 2 squared minus y minus 1 squared over 16 is equal to 1. So there's our formula. Now that we've got our formula, we can go ahead and do the things we need to do to graph it. So the center is going to be negative 2, 1. So negative 2, 1 is right there. My a value, my a squared is equal to 1, so a is equal to plus or minus 1. So because it's underneath the x in the x direction, we're going over 1 and 1. This is going to be really tight drawing. B squared value so b squared is 16, so b is plus or minus 4. So we're going to go up 4, 1, 2, 3, 4, down 4, 1, 2, 3, 4. There's our little drawing. Just to do, so c squared is equal to 1 plus 16. So c squared is equal to this plus or minus the square root of 17, and that's good enough for there. If you want to just draw the write the asymptote right now, kind of the asymptote, it's y is equal to plus or minus up 4 over 1. So 4x, and again, there is plus something there, but we're not going to worry about that part right now. That's just our general start. Okay, so we draw, I'm going to change colors here. So we draw our horizontal lines. Draw the horizontal line, draw the horizontal line. Draw the vertical line, draw the vertical line. Asymptote line there, asymptote line, eesh. kind of there. Things are moving a little bit. That's really bad, but it's going to look like an X, so it's going to look something like that. Okay, so there's the first one. I'll be back. I'm back. So there's the first one. Like I just said, probably, but then I had to go, and then I came back, and I said it again anyway. Okay, so it's all really, again, about writing it in standard form. Okay, so let's look at a second one. We'll do this one together. The second part, we'll do this together. And this is the last example that we're going to do, and I think we'll just do this one through, we'll work it out all the way. Okay, so how do we know it's an ellipse? We've got negative x squared plus 3y squared. Okay, so we've got a negative x squared. So we're going to rewrite first, just like we did before. But this time when I rewrite this, I always want the positive to be first. So I'm going to put y first. So we're going to go 3y squared minus 6y minus 2x squared plus 4x equals 29. So there's step one. Positive and 1. So we got to factor out a 3. So that leaves me with y squared minus 2y, half of, so plus 1. So our box would be plus 1. Now we're going to take a negative 2 out of there. So that's going to leave us with x squared. 4 divided by negative 2 is negative 2x. And again, we're going to put plus 1. So we've got 29. Distribute. So over here, distribute that over. So I've actually added 3. And here, negative 2 times 1 is negative 2. So I've actually subtracted 2. Okay. So that leaves us with 3 times y minus 1 squared minus 2 times x minus 1 squared equals 30. So you're going to divide by 30. So we get y minus 1 squared over 10 plus x minus 1 squared over 15 is equal to 1. And nothing wrong with that. That's okay. Center. Center is going to be at, got to be careful, got to switch around, but they're both negative 1. So our center is at 1, 1. So our center is right there. The vertex, our a value is 10. So y comes first, our a value is 10. So a squared equals 10. So a is equal to plus or minus the square root of 10. And by approximation, the square root of 10 is 3 point something. It's 3.12. So from my graph over here, I'm going to go 3.12, and it's underneath the y value, so I have to go up 3.12 and down 3.12. So 1, 2, 3. So about right there. And about right there, somewhere in those directions. So my vertices essentially are 1 and 1 plus radical 10 and 1 minus radical 10. Again, you're okay as long as we graph it, you don't have to list them. My b squared value is 15. So b is equal to plus or minus 15, which is about 3.9. So from there, we're going to go over 3.9. So 1, 2, 3. So about right there. 1, 2, 3, about right there. So this is a y equals, so let's find c first. So that's 10 plus 15, nice. So c value is plus or minus 5. C equals plus or minus 5. Okay, so we got our c value, our asymptote line. Y is equal to plus or minus. Again, it's rise over run. So this, in this case, it's going to be radical 10 over radical 15. Eesh. Radical 10 over radical 15, which obviously we can't leave, which is radical 2 over radical 3. which of course we can't leave, so this becomes radical 6 over 3, yuck, times x. Actually, I probably would have been happy with any of those answers. Whatever. Okay. Draw our horizontal lines. Draw our vertical lines. This one I can see I'm going high tech with this one. Something like that. Y comes first, so since Y comes first, it's going to go up and down. It's going to go something like that. Okay, it's kind of a crude drawing of what this looks like. So there, in 2 parts, sorry, is hyperbolus. My watch is telling me it's time to stand, which means I've been sitting down here for about 45 minutes, 50 minutes. I did get up, whatever. So your assignment, I'll post it up there. I don't remember what it is, and I don't have it anywhere, so I'll post the assignment over there somewhere on the video. Get that taken care of. Tomorrow's lesson will be kind of an intermix of all of them, where you have to figure out exactly what's going on and figure out which one you need to use, and get a little bit of extra practice with completing the square and doing these things. And we're looking at a test over this material like 3 class periods from now. So probably next, if you're watching this on Friday, that means next Tuesday that we will be doing this. So have a great day, everybody. It's raining outside right now. It's kind of gloomy. It is what it is. Have a great day, everybody.